oscillatory motion. So these things you can mark in your textbook. So what he is telling, see, so this is the pendulum. Okay, with a small thread we are trying to suspend the ball. Okay, so when we are taking this ball to one side and when you are releasing, what will happen? How much distance, whatever we have taken from O to B, if we are taking some distance from O to B, so the same distance is being covered from O to A again. Again, it will come back to its original position. So O to B is equal to O to A. Understood?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Clear? So same distance it will cover. So the pendulum is said to have completed one oscillation when its bob starts from its mean position O. So this is the mean position O. Okay. O to A and to B and back to O. The pendulum also completes one oscillation when its bob moves from an extreme position A to another extreme position B and comes back to A. The time taken by the pendulum to complete one oscillation is called its time period. So when it is starting from O, when it is going to A and coming back to B and coming back to O, then the pendulum has completed one oscillation. Okay, we can say that thing. So so whatever time it is taking to complete one oscillation, that time is called as time period. Understood?
Yes, ma'am.
Clear with everyone?
Yes, ma'am.
Tejas, Himesh, Abhishek, understood?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So, I set up a pendulum, simple pendulum as shown in figure, with a thread or string or of length nearly 1 meter. Switch off fans nearby. Let the bob of the pendulum comes to the rest at its mean position. Mark the mean position of the bob on the floor below it or on the wall behind it. To measure the time period of the pendulum, we will need a stopwatch. However, if a stopwatch is not available, a table clock or a wristwatch can be used. To set the pendulum in motion, gently hold the bob and move it slightly to one side. Make sure that the string attached to the bob is taut is taut while you displace it. Now release the bob from its displaced position. Remember that the bob is not to be pushed when it is released. Note the time on the clock when the bob is at its mean position. Instead of the mean position, you may note the time when the bob is at its extreme position. So what he is telling, understood? What
Yes,
he is telling, understood? What he is telling, tell. What he is telling.
ma'am. Can you repeat, ma'am?
See, already he has told about simple pendulum, right?
Ma'am.
So how simple pendulum will work? When you are taking that pendulum thread, when that ball is attached to that string, and when you are bringing the ball from its mean position, which is 0 or which is at rest O, if you are getting that one to one extreme end, either it might be A or B, to any extreme end, you pull the bob. And when you release it, don't push the bob. He is telling not to push the bob. Just you pull the bob and just leave it, like how we are swinging in a swinger. How we swing in a swing?
And we
Ma'am,
push,
we
ma'am.
put out a foot, ma'am.
Only just with the help of our legs only we will try to go back and come forward, right? In the same way, take this ball and just try to leave that ball. So from one extreme position, it will go to another extreme position, and again it will come back to its normal position from where it has been started.
Yes, ma'am. I got it.
So that only is important. All these activity are not important. So this is the major important thing, simple pendulum. Understood what he is telling?
Yes, ma'am, I understood.
Everyone understood? Abhishek,
Yes, ma'am.
clear?
Yes, ma'am.
Yes, ma'am. Understood, ma'am.
Tejas, Vedesh,
Yes, ma'am.
Yes,
clear?
ma'am.
So measure the time the pendulum takes to complete 20 oscillations. So in this manner, he is asking us to measure the time, one oscillation, how much time it is taking to complete one oscillation. So what is one oscillation? One oscillation means from one extreme end to another extreme end and again coming back to its mean position only is called as one oscillation, right? Yes or no?
Yes, ma'am.
That is only called as one oscillation. So in that manner, he is asking us to calculate the time. So one oscillation is a one to complete one oscillation. How much time the pendulum is trying to take, or the ball, how much time it is trying to travel. So that thing he is asking us to check. So the first observation shown is just a sample. Your observations could be different from this. Repeat this activity a few times and record your observations. By dividing the time taken for 20 oscillations by 20, get the time taken of one oscillation or the time period of the pendulum. So understood. So one
Yes, ma'am.
oscillation, if 1 minute somebody has 1 minute. So what he is telling, repeat this activity a few times and record your observations. By dividing the time taken for 20 oscillations by 20, get the time taken for one oscillation or the time period of the pendulum.
Yes, ma'am.
So if we are calculating the time period, or if we are repeating the same experiment for number of times, we get different readings, right?
Yes, ma'am. We
Or
get different feeling.
when you compare those readings with different people, so each and everyone will not get the same readings, yes or no? They will get different readings.
Yes, ma'am.
So in the above part, what he is telling, measure the time the pendulum takes to complete 20 oscillations. He has already given 20 times. 20 times you have to check 20 oscillations, how much time it has been taken for the pendulum. So to find out the time period of the pendulum, what you have to do, by dividing the time taken for 20 oscillations by 20, we will get time taken for one oscillation. That is only called as the time period of the pendulum. Understood?
Yes, ma'am.
ఏం చేస్తున్నావు? So is the time period of your pendulum nearly the same in all cases? Note that a slight change in the initial displacement does not affect the time period of your pendulum. Nowadays, most clocks or watches have an electrical circuit with one or more. Huh? So what will be the time period when we are taking number of, see, when you are calculating number of times, the time taken for 20 oscillations, whatever we are calculating, it will be same or it will be different.
Ma'am, it will be different, ma'am. For someone, it will be different. For someone, it will be different. So, when we take the first oscillation, then we have to multiply it by 29.
Yes, no one will get the same readings. Yes, no one will get the same readings when we singly we are doing for 5 6 times. At that time also we don't get the same readings. Okay,
Yes, ma'am.
understood.
Yes,
Ma'am,
ma'am.
can you tell again more?
What happened? What happened? Understood or not?
Ma'am, understood.
What he is telling, say? What he is telling?
Ma'am is telling that, ma'am, at a time, ma'am, if you see, ma'am, about the 20 oscillations, ma'am, if you repeatedly check, ma'am, each time it will come different.
Yes. Each time we will get different values only. We will not get the same values. Why? Because there will be a change in the way we start the bob when we are trying to push or pull the bob. At that time velocity will be different, and the way we are releasing also, that energy also will be different. So
And then
there
due to friction, it will gradually start to decrease the speed, ma'am.
yes. So understood what he is telling.
Yes, ma'am.
So this activity is not that important, but what you have to understand is this to and fro movement of the pendulum only is important. Okay, in this to and fro movement pendulum, and the time taken by the pendulum to complete one oscillation is called time period. These are only important. Understood?
Yes, ma'am.
Yes, ma'am.
So the clocks are called quartz clocks. The time measured by quartz clock is much more accurate than that by the clocks available earlier. So unit of time and speed. The basic unit of time is seconds. Its symbol is S. Larger unit of time are minutes and hours. Yes or no? If you are checking for time, we will write either time in hours or minutes or seconds. Correct or not? We will denote
Yes,
time with those units only, no? Hours,
yes, ma'am.
minutes, or seconds. You already know how these units are related to each other. So 1 hour is having how many minutes?
60.
60,
So 1 minute is having how many seconds?
60.
60.
So that is only the interlink between hours, minutes, and seconds. What would be the basic unit of speed? So generally, when we are measuring the speed, we will measure either
Meters per
in
second.
meters per second or in kilometers
Mm.
per hour. Okay. Since the speed is distance by time, so total distance covered by total time taken. If we are calculating that, we are getting the speed of the object. Okay, the basic unit of speed is meter per second. Of course, it can also be expressed in other units such as meters per minute or kilometers per hour. Okay, you must remember that the symbols of all units are taken in singular. For example, we write 50 kilometers and not 50 kilometers S. We are not going to write S, or 8 centimeters and not 8 centimeters. S won't be there. CM or KM only. Bojo is wondering how many seconds are there in a day and how many hours in a leap year. Can you help him? So different units of times are used depending on the need. For example, it is convenient to express your age in years rather than in days or hours. Yes or no? If you want to tell your age, you will tell how you will express your age in years only. You will express, right? Not in days or year, not in days or hours. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
10 years, 11 years. So we will represent our age through years only. In the same way, time taken by you to cover the distance between your school and your between your home and your school. How small or large is a time interval of 1 second? The time taken in saying aloud 2001 is nearby 1 second. Where verify it by counting aloud from 2000 2001 to 2010. The pulse of a normal healthy adult can be rest beat at rest beats about 72 times in a minute, that is about 12 times in 10 seconds. This rate may be slightly higher for children. So generally our pulse rate, how many times the heart will beat? 72 times the heart will beat. Okay, so that means what? Almost in a minute it is about 12 times or 10 seconds. 12 times in 10 seconds. Understood?
Yes, ma'am.
What about others?
Yes,
Yes,
ma'am.
ma'am.
Understood. Yes, ma'am.
So many time measuring devices were used in different parts of the world before the pendulum clock became popular. Sundials, water clocks, and sand clocks are some examples of such devices. Different designs of these devices were developed in different parts of the world. So now check what are sundials and so this is one sundial. Sundial at Jantar Mantar. This is sand clock and this is water clock. Clear? So before we were having pendulum, we used to see these things based on these instruments only. We used to measure or we used to tell the time. Understood?
But ma'am, it is not easy to calculate the time.
That time approximately they used to say exactly 5 like that. They were unable to say all those things. So, measuring speed. Having learned how to measure time and distance, you can calculate the speed of an object. Let us find the speed of a ball moving along the ground. Draw a straight line on the ground with chalk powder or lime and ask one of your friends to stand one 1 to 2 meters away from it. Let your friend gently roll a ball along the ground in a direction perpendicular to the line. Note the time. Note the time at the moment the ball crosses the line and also when it comes to rest. How much time does the ball take to come to rest? So this is the experiment. He is asking us to draw a line and from here he is asking you to throw the ball. Okay? Measure the distance between the point at which the ball crosses the line and the point where it comes to rest. You can use a scale or a measuring tape. Let different groups repeat the activity. Record the measurement in table 13.3. In each case, calculate the speed of the ball. You may now like to compare your speed of walking or cycling with that of your friends. You need to know the distance of the school from your home or from some other point. Each one of you can then measure the time taken to cover the distance and calculate your speed. It it may be interesting to know who among you is the fastest. Speed of some organisms, living organisms, are given in table. So what he is telling, when you are throwing the ball, when you are trying to roll the ball on the ground, so if you are putting more pressure on the ball and if you are releasing the ball will go little bit, the ball will go little bit faster. In the same way, if you are throwing the ball little bit with light pressure, just you are trying to roll the ball, then the ball will travel. What will happen? The ball will travel. How much distance it will travel?
Ma'am, can you repeat once, please?
See the active figure 13.6. Okay. Mm, 13.6, what he is telling, at one from one point of place, you try to roll the ball on the ground. So that rolling of the ball will depend on what conditions are what. If you are trying to roll the ball with a greater force,
Then it will go much more speed
then
and more.
it will travel more distance, right? The ball will travel much more longer distance. In the same way, if you are not putting that much effort or that much force, and just you are trying to roll the ball on the ground, then what will happen? Then the distance covered by the ball will be very much less than the first time what the ball has been covered, right?
Yes, ma'am.
Speed of the
But
ball will get reduced or not?
yes, ma'am, it will get reduced, obviously.
Yes, that's what he is also telling, the same thing. Understood?
Yes, ma'am.
Ma'am, it will reduce.
It will reduce, obviously, if we are not using that much force, and if you are just slightly rolling on the ground, then the distance whatever it has been covered in the first situation, it won't cover the half of the distance also. Understood?
Ma'am, because friction will always stop the ball, ma'am.
Yes, that if we are putting more amount of force, then the ball will try to travel more distance, right? It will go more faster, and it will cover more distance. In the same way, if you are not using that much force, with less force, if you are trying to push the ball or just to roll the ball, what will happen? It will not cover that much distance what it has been covered in the first situation.
Ma'am, I think that friction always tries to absorb energy. So when we throw the ball with more energy, friction will take more time to absorb the energy, ma'am. So
Yes,
the
so that
ball
it will travel, it will travel more distance.
Yes. So, ma'am, if the friction does not exist also, then the ball can go infinitely. It will go on, ma'am.
It will be
If
going on
less,
only. If there won't be, say,
Ma'am,
yes,
if a smooth floor or any polished floor is there, ma'am, then less friction there, ma'am. It will go speed, ma'am.
what happened?
he's
It
stating that when smooth or polished floor, if we still go push it at a slighter speed, then it will go much more speedier than the other floors,
Yes,
ma'am. That
yes,
is what
yes,
that guy is
yes,
saying.
yes, it can travel more distance.
okay because it absorbs less because friction is less.
Yes, correct.
ma'am, then why can't we throw a ball? Then if we throw a ball in space, ma'am, when there is no air, only vacuum is there, then why
Or
will it?
no gravity, no
No, it will
gravity, no
float
air.
around. It will float around because there is no
It will
It
surface.
will,
float. Why will it
it
float,
will.
ma'am? It should go infinitely, no? I will throw
Yeah,
with lot
it will
of
go
force.
infinitely. Yes, because there is no
See,
surface. It will go on infinitely.
when you are throwing, we are having gravitational force, right? So
Yes.
whatever we are throwing, due to gravitational force, everything will come down only.
No, ma'am, I'm not telling that it will not come down. But
Ah,
I'm telling that if we throw the ball, how much ever force we throw, it will just start floating. Why will not it go forward, ma'am? It will just start floating, right? Why will it float? Why shouldn't it go
In
front?
space,
In space.
In vacuum. because no gravity is there. That's why.
And there is no surface. That's why.
Because no center of gravity is there. Any gravity is there. That's why it's not there.
Unless it reaches your body, then it will go float around. If it reaches near a body, then it will go there.
In vacuum, no mass is there in any of the objects. That's why it floats.
So understood, clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Clear with everyone?
Yes, ma'am.
Yes, ma'am.
So the same thing he is also telling. See, rockets launching satellites into Earth's orbit often attain speed up to 8 kilometers per second. On the other hand, a tortoise can move only with a speed of 8 centimeters per second. Can you calculate how fast is a rocket compared with that of tortoise? So once you know the speed of an object, you can find the distance traveled by it in a given time. All you have to do is to multiply the speed with time, then you will get distance. So anyhow we know, right, speed is equal to total distance traveled by time taken. Already we know. So whatever they are giving, if they are not giving distance, if they are giving speed, so distance is equal to speed into time.
Ma'am, but
Understood?
then how will it help us to uh, calculate the difference in the speed, ma'am?
Ah,
How will it help us to calculate the difference in the speed, ma'am?
for difference in the speed we are not using this formula, we are using just for distance covered speed only, or speed of an object. Okay, no comparisons, only one object. So speed of an object is equal to distance covered by time taken. That's it. So if you want to calculate the speed for two different objects, both the ways you have to do in the same manner only. Speed is equal to distance by time taken. So then you have to compare which speed, which person's speed is greater or lesser. Understood?
Yes, ma'am.
Yes.
Yes, ma'am.
So if he is asking us to calculate time taken, then distance covered by speed. So whatever he may ask, only one formula, speed is equal to total distance traveled by time taken. So based on the things what he has given, whether he has given speed or time or distance, we don't know. Based on those things only you need to do the sums. Okay, according to that we have to convert. If he is asking distance speed into time, we have to write. If he is asking time, distance by speed, we have to do. In the same way, if he is asking speed, distance by time, distance covered by time taken, in that manner you can modify the formula according to the things what he has given. Based on that we have to change the formula and do the sum. Clear?
Clear, ma'am.
What about others? Clear?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So you might have seen a meter filled on top of a scooter or a motorcycle. Similarly, meters can be seen on the dashboards of cars, buses, and other vehicles. Shows the dashboard of a car. Note the Note that one of the meter has kilometers per hour written at one corner. This is called the speedometer. It records speed directly in kilometers per hour.
Ma'am,
Yeah.
ma'am, how it works, ma'am? Speedometer.
So kilometers are there. No, by the time if see car is traveling automatically, if you set this speedometer to zero, how much distance we have covered in in one particular day, almost everything he that you will get in this speedometer.
Ma'am, how it works, ma'am?
Odometer. Hmm?
How it works?
Which one?
Speedometer.
See, we are having two things. One is speedometer and the one is odometer. Speedometer means the speed of the car. When you
Yes,
accelerate the car,
yes.
when you're starting with this 20 kilometers, when you again raise the acceleration, when you when you go speed when you go very speed, obviously it will go to 80 kilometers. So that is called as the so that is the speed of the car, right? Yes or no?
Yes, yes.
At what speed we are going, so that is only called as speedometer. It will show the speed of the car or a bicycle, or not bicycle, or a bike or bus. So at what distance, at how much speed the bus,
Any motor vehicle.
any motor vehicle, with how much speed they are traveling, that will be showing on the speedometer. And the small one is there, right? Kilometers is there, right? That is called as
Kilometer. Kilometers.
odometer. That will show us how much kilometers we have traveled till
Ma'am,
date.
nowadays digital is getting, ma'am. Digital odometer, ma'am.
Digital odometer, digital speedometer, all those things we are getting now digital only.
But,
Ma'am, my
ma'am, but,
father is all digital odometer and digital speedometer is also there, ma'am. Both are everything is
ma'am,
digital.
ma'am, my father car have analog speedometer and digital odometer
Okay,
in my father's car.
okay. So odometer means it will try to measure the distance moved by the vehicle. So if we are traveling 50 kilometers in a day, so obviously it will show 50 kilometers. And next day, if you are not resetting, if it is going in that manner only, next day if you are traveling 100 kilometers, so this 50 plus 100, 150
They will say
kilometers
one
total this much kilometers we have traveled till now. It will show in that manner.
Ma'am, if we forgot to set in zero, ma'am.
So generally, some people when they are going on vacation, when they are going on car to vacation, generally they will set the odometer to zero so that they can have an idea how much kilometers they have traveled. So for that sake, they will do in that manner. Okay.
Ma'am, my father also did, ma'am. To airport, ma'am.
So first one more thing is just that is to measure the distance. So if you want to check any distance from one place to another place, like from our house to airport, if you reset the odometer, it will show the distance between your house and the airport. Okay, how much kilometers, all those things, kilometers, everything we can come to know based on that only. If you are setting the odometer to 0.
Yes, ma'am.
or
One button is there to set the odometer, ma'am.
or one more thing is there. If you don't want to set the odometer, what you have to do, you have to take the initial reading, means before starting the car you have to take down that reading. And again, what you have to do, once you reach the destination, then when you are stopping the car, before that you have to take one more reading of the odometer. Then
Then
if
we have
you
to,
subtract, then only you will get how much distance you have traveled.
Ma'am, our family went on road trip from here to West Bengal. Ma'am, total distance covered was more than 3,200 kilometers. We set the odometer to zero and it showed.
ma'am, I also set the odometer, ma'am. We go to Telangana to Andhra Pradesh, ma'am, for traveling. We set the odometer total is 200 kilometers.
Ma'am, my digital operator said that when we are going to my hometown, it was said that it was like 365 kilometers, ma'am, when we reached there.
Yes, ma'am. Mine also digital, ma'am.
Okay.
Ma'am, how odometer works, ma'am?
how
Ma'am, how?
odometer works?
Yes.
Black icon. See, all those things, odometer, speedometer, they are connected to the. Generally, if you take a car, where it will get connected. It will get connected to the
Ma'am, I
engine
think they will have sensors.
sensors.
Ma'am, in some mechanical only it is connected to wheels, ma'am. In some mechanical engineering.
Ma'am, we can, if we can do some maths, ma'am, we can only like calculate that how much we went, ma'am. If we do some hard mathematics.
That's what I am telling. How much distance we have traveled, all those things we can come to know. If you reset the odometer, one thing is, if you reset the odometer, we will get the distance how much we have traveled. Otherwise, one more thing what we have to do is we have to find out the, before starting the car, what is the reading of the car before starting. You have to take down, and after we reach the destination, that time also we have to take down the readings. So from the destination, so the number what we got when we are checking after destination, from that number if you subtract the initial reading, you will get how much distance you have traveled. All those things you will get. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Ma'am,
Yes.
ma'am, are you there? Okay.
It is not at all clear.
Nothing, ma'am.
Okay. So, while going for a school picnic, Paheli decided to note the readings on the odometer of the bus after every 30 minutes. till the end of the journey. Later on, later on, she recorded her readings in the table. Can you tell how far was the picnic spot from the school? Can you calculate the speed of the bus? Looking at the table, Bojo tested Baheli whether she can tell how far they could have traveled till 9:45 a.m. Paheli had no answer to this question. They want to their teacher. They went to the teacher. She told that one way to solve this problem is to plot a time distance time graph. Let us find out how such a graph is plotted. So they are different ways, either through distance time graph. So either through a graph you can represent, or through a pie chart you can represent, or in this format through the line graph format you can represent. We are having different types of graphs to be to that given data. In that manner you can mark all those things, and you can represent them on the graph papers. Okay, so anyhow you know how to draw a graph, how to draw pie chart, all these things you know, right? Already you people have learned or not?
Yes, ma'am. We learned in maths class.
Yes, ma'am, we learnt it.
In max, yeah, I think so you people have learned how to draw a graph, how to take the measurements, and how to write the scale. All these things you know, right?
Yes, ma'am.
What we have to take on x axis, what we have to take on y axis. If it is a bar graph, how we have to draw the bar graph. If it is a pie chart, how we have to draw all those things.
We learned, ma'am.
All those things I think so you have learned in max class, actually in max. So what we will do is this distance time graph we will start on Monday. You won't get any questions from this graph, but only just simply how how we are plotting the thing on the graph. Only that only he is telling. Other than that nothing he is telling in these things actually. Okay, see, distance we are taking it on x-axis, and time we are taking on x-axis, and distance we are taking on x-axis. So 1 minute is equal to 1 centimeter. All those things, how we are taking all those things, he is telling in detail. So this part we will continue on Monday. So what about tomorrow's test? Tomorrow any test you are writing, or you will take break for this week?
Ma'am, we can do go on with acid bases and so.
Yes,
Acids, bases, and salts. MCQs you people will write tomorrow.
Yes, ma'am. Yes, ma'am.
yes, ma'am. But
Yes,
today
ma'am.
we should write question answers, no, ma'am.
Question answers. Question answers I did not give, right. Yesterday only I posted the question answers in the group. So next week we will go with question answers, or for now we will leave the question answers. Okay. Why?
Yes, ma'am.
Because some
I,
children have missed the class, right?
yes.
Okay, ma'am.
Some children have missed acids, bases, and salts, right? How can we ask them to write the question answers for next week? I need to repeat that chapter again. Okay.
Okay, ma'am.
So acids, bases, and salts, and time and motion. For time being, I will just teach, but we will not write any test in these two chapters. Let everyone come back from the vacation, then again I will teach these chapters when school starts again.
Okay,
Clear?
ma'am. Okay, ma'am.
Okay, ma'am.
So now for Vedesh, I need to complete. So this week we will write only MCQs, test in acids, bases, and salts. Okay.
Okay, ma'am.
Okay, ma'am.
Okay, ma'am.
And once check Vedesh in your book, you are having distance time graph. Why? Because last year also teachers they did not teach this distance time graph.
Okay, ma'am. I will check.
What's the chapter number? Chapter number is
Ma'am, motion and time?
yes, ninth chapter or tenth chapter.
Ma'am, in this textbook it is ninth.
Ninth chapter. Okay.
I'm in knowledge. It is chapter number 1, but now it's 9.
Nine. It is there. But here also we need to check. 1 minute, wait.
Ma'am, you are there?
What happened?
I think rooms are can be used.
Ma'am, can we leave?
Yes, you can leave. Monday we will continue distance time graph. Okay.
Okay,
Okay,
ma'am.
ma'am.
Thank you, ma'am. Bye, ma'am. Thank you, ma'am.
Bye, ma'am.
Bye.
Thank you, ma'am.